I don't know if this will work or not, so we're going to give it a shot. If my dogs bark, I apologize. They hate the UPS man, and he was just here. All right, so what I'm going to do first is I am going to head over here, not in that folder, but over here to my, oh Lord, Launchpad. I have a Mac, so it's a little bit different, but you're going to use your SPSS, and it's going to take a minute, and that's okay. We're going to let it open. And this way we can open our SPSS. Okay, so when you open it up, it is going to show up like this, right? And we can pick, I have recent files here, but I'm not going to do that to you guys. I'm going to pick a new data set. And so I'm going to click new data set. And then I'm going to click open. And so it's going to tell it's wanting to get a new file. So we're going to do file, data, and then it's going to ask me what I want to open. So you guys, I would suggest having it on your desktop. I'm going to open mine from here and see I have all of these saved, but I actually want to show you guys how to come down here, and we are going to open an Excel spreadsheet. So see, when I do that, all of my Excel stuff comes up. So I will pick the 2009-2010. I will click open. And then remember, I warned you guys about what's going to happen here. So you want to make sure that you see all my results. You want to make sure that you click the one with the data. So there's the data. You want it to read the variable names from the first row of data. That's what gives you your variable names here. Data type, ignore hidden rows and columns. That shouldn't be a problem. And then you're going to come down here and you're going to click OK. So then when you do that, it should, see, this is all syntax, and it's telling me that I want who the user is, what the desktop is, what all this stuff is. My stuff opens really small down here, so we're just going to go ahead and open that. And so we have two views here. And right here, I am actually in variable view. And you can see that variable view, I have all of my variable names here. Complaint ID, child ID, it tells me it's numeric. It gives me the width. It gives me the decimals. I don't have any decimals, but you can change these. So if I wanted to change them down to just 2 decimals, which is much easier to work with, you can do that in here. You don't have to, but you can. All right, so we're at variable view. We can toggle over to data view. And when we do that, it looks just like our Excel spreadsheet. So again, at the top, we have all of our variables, and each down here we have what our variables contain. So you can see, and you can do the same with these that you would in Excel. Gender, race, complaint date, all of these stay the same. Analyze is our main function. Descriptive statistics, in here we have frequencies and we have crosstabs. So with our frequencies, this is where I talked about, let's do one here, grade level. This is kind of, you can do this kind of like we were doing crosstab tables, but these are not crosstabs. This is just figuring out what's happening here. So statistics, we don't want to use any of this because it's a discrete variable. So you'll hit continue. You can make a chart if you want. So if you wanted a bar chart, you could do that. And it's going to give us frequencies, not percentages. You can click whichever one you want. And then you can click OK. And it's going to pull it up in another page called an output. And so this one tells us I have 930 cases, none were missing. I have 171 students in first grade and on down till we get to 930. This gives us our percents, and this gives us our cumulative percents. And then right below that, it gives us a bar chart of what our data looks like. So pretty nifty when you're just doing frequencies. We can also do, you got to go back to descriptives. You can do a crosstab. And so with our crosstab, we could do previous grade failure on our rows, special education status on our columns, you are going to ask it when you do this for a chi-square. We need a chi-square, right? So chi-square is right there. In our cells, we want our observed values and our expected values. Don't click any of this stuff because it's going to get really ugly really fast. And once we do that, we're going to click OK. And now I have what looks like it kind of does in Excel. So I have 930 cases. There were no cases missing. And so what my percent was. Right here we have our count, our expected count. I have 0, 1, 2 for special education status. This hasn't been recoded. Or previous grade failure 0, 1, 2. So you can see we have our counts, our expected count, and then our totals with our grand total down here. Column totals, you won't need to do any math though because count and expected count are here. So we come down here to our Pearson chi-square. Here's our chi-square value. Here's our degrees of freedom. Here's our significance. This is significant. And so we would need to come back up here and figure out what makes this significant. I picked bad variables, but what you would do is you would come up here and you would say, oh, well, they only expected 176 and there was 187. Or they only, there was only 51, but they expected 64. So you want to figure out what about previous grade failure and special education is kind of interesting to figure out what in here would be significant. And you're always comparing the expected count to your observed count to kind of figure out that likelihood. I'm going to go ahead and do this with my other variables so that I can talk about it more succinctly and it makes sense. I have recoded these, and so I'm going to use the recoded ones. Previous grade failure on my rows, special education on my columns. All of this stays the same. So my chi-square is still checked. My cells, my observed and my expected are still there. Then I'm going to click OK again. And it's going to pull up a new one. In this recoded variable, our N is only 912. We have 18 missing cases. So when we come down here, this is no, this is yes, this is no, this is yes. We come down, it actually is still significant. So we need to come up here and figure out, okay, so these are the kids who have been, who have previously failed, and these are the kids who are in special education. And look, we only expected 18 of them to be in special education and have failed a grade. And what we find is we have almost double that in our special education classes who have also failed a grade. This is a problem, right? We have less than expected up here, not a problem. This is actually a good thing, or this is actually a good thing. We have more than expected who were not in, who had never failed a grade and who were not in special ed. So that one doesn't really matter. It's this one right here that is causing us some trouble. So what you would talk about is you would say there was a significant association between previous grade failure and special education, and it would appear that more kids have both failed a grade and were in special education than expected. And that's a problem. You get to talk about why that's a problem. You'll notice down here too, 0 cells have expected counts of less than 5 and what my minimum count is, all of that. You don't need any of these other numbers except for we ended up with 912 cases instead of 930. So this is a cross tabulation with a chi-square. All of the math is done for you. On this one, we can also look at correlation. We're going to use bivariate. And I'm going to use a Pearson's first. And I want to look at, so I'm going to look at the number of unexcused absences after referral. And this is called function score, but it's basically their risk score. So here's Pearson's. It's two-tailed. I want it to flag significant correlations. I don't need any of this information. We're not bootstrapping anything. We don't need any of this. All right, so we have it all checked off here. So I'm going to click OK. And as you can see, our correlation comes here. The reason this is 1 is because this is corrected unexcused absences and this is corrected unexcused absences. This is our score and our unexcused absences. And as you can see, our Pearson moment correlation coefficient is 0.127. These two little stars mean it was significant. And if you come down and look at the significance, it's also significant here. We have a total of 930 cases. It is both significant and positive. So you would say there was a significant correlation between the pre-program assignment score or their function score and the number of unexcused absences after referral. So what this means is as the as that function score, risk score goes up, so do their absences after intervention. It's a problem, right? Did our intervention work? I don't know. I mean, I do know that it works, but for this one, this would cause you pause because you'd be like, okay, well, higher risk kids are still missing school at a greater rate. They're still having more unexcused absences than their counterparts. So the other thing we could do is if we want to do a bivariate correlation, it's always bivariate. All right, and so we want to do this, let's say, so we found that this up here, this previous grade failure and special education status. Well, we can also do this down here. I'm going to use these same recodes. I'm going to put them in. And then I am going to, instead of, you can go ahead and let it pull a Pearson, but what you really want is a Spearman's row. And we're using a Spearman's row because we've violated the assumptions that in a correlation we are going to have two interval ratio level variables. Instead here we have 0, 1 variables. So 0, no, or 1, yes about failing a grade, 0, no special education, 1 special education. So we'll just click OK, and it's going to come out the same way. It's positive and significant. Here's our significance. Here's the positive. It's the same down here, right? You see the ones. That's because it's correlating against itself. So you're going to use these numbers. Remember how in Excel it didn't have this number up here? In SPSS it does. So we have 912 cases. This is positive, which we would expect. This further tells us that our relationship is happening, right? So there is a significant positive correlation between grade retention and between grade retention and special education. So as a child in special education is also more likely to have failed a grade, is kind of what this is saying. It's definitely something to talk about, right? You don't want kids in special education also failing grades. It's a problem. We know that it becomes a risk factor in other ways. So that, in a nutshell, is going to be what we're looking at. I did also want to show you guys a frequency that is a continuous variable. So I want to look at, oh, not that one. We are going to look at function score. And you see a little ruler next to it. That little ruler means that it is a continuous or scale level variable. So in our statistics then, I want to do mean, median, mode. I want it to give me quartiles. I want it to give me the standard deviation, the variance, the range, the minimum, the maximum. Look, I can even do skewness and kurtosis. Now we can continue. If I want to do charts, I can do a histogram, right? I can show the normal curve. So these are other things that we can look at. So this one, what we find is we have 930 cases. The mean score is 30. The median score is 25. The modal score is 18. So we don't have a normal distribution here. Standard deviation is about 17. We have a huge variance, which goes along with our standard deviation of about 17 points. Skewness is 1.9. We are right on the verge. 2 is our cutoff. So we are right on the verge of having a very skewed distribution. Kurtosis is positive, which means we're probably going to see a leptokurtic tall curve. Range is from 6 to 147. Those are our scores. Oh, sorry, 6 to 153. Percentiles. So 25% of our cases were 19 and below on their scores, 50% were 25 and below, 75% were 36 and below, which tells you that we've got the 75 to 100 is kind of high. And you can see it here. So see, this 25 is 19 and below. This 50 is 25 and below. So you get the idea here. But this gives us the idea of how the function scores played out. We have somebody out here that had 153. So when we get to 75% and above, we're getting really high risk here because we are looking at here. So here's 75%. So here's our 37. This ranges from 37 to 115. It's kind of strange. So as you can see, our mean might be 30, but we have a pretty wide distribution. So I did want to show you guys that too, so you can get a better picture of what's happening. All right, if you have other questions, we can talk about it again. Sorry, I know I'm probably making some of you dizzy. But I wanted to go ahead and get this up so that you guys had an understanding of how to get this done and how to read and how to get it all done. So you can do a file, save as. I would title your data set. So we could do this for class. And then you want to pick where you're going to save it. So I'm going to save it. I'm just going to put it in here. It's fine. So I'm going to save. But then I also want to come down here. And you want to make sure that you're saving your output. So you need to save it separately because it won't save it together. So save output as and be very specific. You might want to say output for class data set version 1. Just something that gives you an idea of what's happening. See, and now it saved my output. I can also export my output. So if you export it here, like we talked about, see how it's going to save it in Word. I can browse where I want it to be. So I can give it a file name and have it saved there. And it will save as a Word document. So you can open it anywhere, email it, so that you don't have to have SPSS. Because once your SPSS trial is up, you will not be able to open these anymore. So I want you guys to be aware of that. All right, I am going to see if I can shut off this recording now and if it worked. So we will know in a minute.